Hello everyone. I'm sure you must have prepared your last lecture and now you're here for continuing the topic where we will be doing more forms of equations of circle. So let us start with more equations of circle, and the first type is in this session diameter form. Now as name suggests, diameter plays its role. So picture would be something like this. That two ends of diameter I have shown as A and B, x1, y1, x2, y2. And again I am showing one moving point on the circle with center C. Now, if anyone wants to derive equation for that person, I am giving the hint. One fact you can always use as AB subtends right angle at point P. That is the property of the circle, correct? Now you can use slope, right, of AP, you can use slope of PB, and their product should be equated to -1. That also can lead to equation of circle. But frankly speaking, from competitive examination point of view, this exercise may take some fraction of second more. So instead of that, I would always suggest, though I'm not a person using more and more formulae, but I would suggest that it's better to remember diameter form separately. And that is why I'm taking effort to explain also that what is our diameter form. Diameter form is x minus x1, x minus x2 plus y minus y1, y minus y2 equal to 0. This form, I mean, it is easy to what we can remember. So nothing special about it. Only endpoints you should know, x1, y1, x2, y2. Which point you name as x1, y1, that also doesn't matter here. Now you can remember this form as x minus x1 into x minus x2 plus y minus y1 into y minus y2 equal to 0. Same form maybe after expansion of using that slope thing what you would have got, and here if you expand would be same. So which form you remember, that choice is yours. Now let us take one example before we proceed to next thing. Now example is, if the ends of diameter of a circle are given as 2 comma minus 3 and minus 4 comma 1, then we are expected to find equation of the circle. Now x1 y1 you have to name. X1 y1 I may call as 2 comma minus 3. I can call x2 y2 as minus 4 comma 1, and I can proceed and I can write equation of the circle. Equation of the circle would be x minus 2 into x minus minus 4 plus y minus minus 3 into y minus 1 equal to 0, and simplify. On simplification, what do you get? X square plus y square plus 2x plus 2y minus 11 equal to 0. Now I have written equation in the standard form like that, x square plus y square plus 2gx etc. Now from examination point of view, I'm saying obviously looking at the option you will be deciding which form finally you should be writing. Okay. Now proceed from here and go to the next one. And the next type is that you write equation in parametric form. What was parameter? We have done in session of straight lines. What was parameter? Parameter is, yes, it's a variable that remains constant for a given case. So obviously in case of circle also we are expecting something to be actually a variable, but it will remain constant for a given case. Okay, I mean keep that in your mind. Now I am showing here one circle with center at the origin, and I am showing that radius as r, and I am taking a point P on the circumference as P, and then I have written inside bracket r cos theta comma r sin theta. If you recall what we had done in trigonometry, you will understand that we have always taken on the circle point as, there it was unit circle, here we have radius r, so we take this point as r cos theta comma r sin theta, correct? Fine. Now what is parameter? We have not yet answered that part. What is parameter? Parameter has to be a variable. So what is varying quantity here? Theta is varying, r remains fixed, so r is a constant throughout, but theta as position P changes will change, right? So parameter is theta. So we should be able to write equation in form of theta now. And what would be corresponding equation of x square plus y square equal to r square? Why I am saying corresponding equation? Because picture what I have drawn here, that actually is related to where we had found equation as x square plus y square equal to r square, right? So I am saying x square plus y square equal to r square, which was standard Cartesian form of equation of the circle. Now that same equation actually reduces to in parametric form as x equal to r cos theta comma y equal to r sin theta. Now this would be called parametric equations of the circle. Now change could be further also. If center is not the origin, but at point suppose h comma k, then corresponding equation of the circle we would have written as x minus h whole square plus y minus k whole square equal to r square. And now we are expected to write corresponding parametric form. So what would be the change? Now I would be writing actually x minus h equal to r cos theta. So it becomes as x equal to h plus r cos theta, and then y becomes k plus r sin theta. And what is theta? It's a parameter which varies between 0 and 2 pi. Okay, so let us proceed further from here. Now two types parametric form we have seen. Okay, so there could be something more to learn. So I take that under important notes. So under important notes, what we learn here is that parametric form of equation of the circle x square plus y square plus 2gx plus 2fy plus c equal to 0. How do we write? Now here center is minus g comma minus f, radius is under root g square plus f square minus c. So in place of r, you substitute under root g square plus f square minus c, and where center had played its role, when center was h comma k, we had written x equal to h plus r sin theta. So corresponding change you will write here, and you will be writing x equal to minus g plus under root g square plus f square minus c cos theta, right? And y would be written as minus f plus under root g square plus f square minus c sin theta. Now this would be the form. Frankly speaking, this I have given under important notes so that you should not feel that if equation is in the general form, then how do we write? But my suggestion to you would be that you better stick to that x minus h whole square plus y minus k whole square equal to r square form. That would be my suggestion. Rest choice is yours. Okay. So let us take one example here and then understand that whatever we have learnt, how it is going to look. The first one is, if x square plus y square equal to 9 is equation of the circle, then any point in its polar form or parametric form would be written as 3 cos theta comma 3 sin theta. And where does theta lie? Theta lies in the interval 0 to 2 pi closed at 0. Now, next my example could be that if any point on the circle x minus 2 whole square plus y minus 3 whole square equal to 16 is to be written, then how we will be writing that point? Now, x minus 2 suggests you that center will have x coordinate 2, and y minus 3 there in the equation suggests you that 3 would be the y coordinate of the center, correct? So you can use that parametric form where center was h comma k and write the point as x equal to 2 plus 4 cos theta. Why do I say 4 cos theta? What is 4 there? Radius. You can see right hand side is 16. So radius is 4. Okay. So the coordinates of any point on the circle would be given as 2 plus 4 cos theta, comma 3 plus 4 sin theta. And where does theta lie? Again in the interval closed at 0 to 2 pi. Okay. Let us proceed further. And the next one in the queue now is that still some more important notes. What would be the first one? How do we get x-intercept and y-intercept of the circle? I mean, where does circle meet the x-axis or the y-axis? How do we start? Now, first is, if I want to get x-intercept, of course, I will be substituting y equal to 0. The moment I substitute y equal to 0, equation just reduces to x square plus 2gx plus c equal to 0. So now it's a quadratic equation, and you know discriminant plays the important role. And now discriminant actually will decide something. Now I say that we will be having, if roots real and distinct, then circle would meet the x-axis at 2 distinct points. I hope you can see the interpretation part. 2 values of x you will be getting, y would be kept as 0. So you will have 2 points where circle would meet the x-axis. So if the roots of x square plus 2gx plus c equal to 0 are real and distinct, then circle meets the x-axis at 2 distinct points. Now next would be, now you can start writing on your own also actually. Now if roots are real and equal, then circle just touches the x-axis. Why do I say touches the x-axis? Because both the points happen to be same only. So of course circle just meets the x-axis at one point, or I can say it touches the x-axis. And if roots are imaginary, then circle does not meet the x-axis at all. That would be the interpretation. Now, if I have to get now y-intercept, then I will have to substitute x equal to 0. Exactly similar steps you take, your equation will become y square plus 2fy plus c equal to 0. Now, if roots of this equation are real and distinct, then circle meets the y-axis at 2 distinct points. And if roots are real and equal, then y-axis becomes the tangent to the circle, or circle touches the y-axis. And the third one would be, if roots are imaginary, then circle does not meet the y-axis at all. Okay. Now, let us go further from here. And of course, without taking example, we can't go. So let us take one example here. An example is that find the length of the intercept on the y-axis by a circle whose diameter is given, and the end points of the diameter are given to be minus 5, 4, and the other end is given as minus 1, minus 2. Okay. So since diameter ends are given, so this suggests me something, that I should actually start with equation of the circle in its diameter form. We write equation of the circle as x plus 5 into, yes, x plus 1 plus y minus 4 into y plus 2 equal to 0. This is the standard diameter form I am saying. Now, question is regarding y-intercept. So, I will have to substitute x equal to 0. And if I substitute x equal to 0, the corresponding changed equation would become now y square minus 2y minus 8 plus 5 equal to 0. And that would lead to, if I factorize straight away, y minus 3, y plus 1. I have deliberately done this part so that I can straight away get y coordinates of the points where circle meets the y-axis, and that would lead to y equal to 3, minus 1. So the actual points are 0, 3 and 0, minus 1. So what would be the length between those 2 points? 0, 3 and 0, minus 1. So that length would be 4. So y-intercept would be nothing but 4. Okay. So we end our session here. When I meet you next time again something new I will bring. Till then, stay tuned. Thank you. Hope you have liked this video. To subscribe, please click on this side, or if you want to place an order for the book, please click on this side. Thank you.